Okay, bit of solar system modelling coming up as promised. I've got an A3 sheet of paper here, which is just a bit bigger than your double page spread. So I've got one ruler to here, which is 30 centimetres, and I've got another about 12 centimetres. I've got 42 centimetres in total. To make it fair with you guys, I'm going to make a mark at 2 centimetres where I'm not going to allow myself to go past that. So I've got only 40 centimetres like you guys. So there we go. Okay. Now, if we remember, the furthest planet away was Neptune, which was 76.3 toilet squares. We're going to halve that, so we're going to call it 38.1 centimetres. So I know I've got 38.1, and I can take that away from 40, which means I've got about 1.92 centimetres in which my sun can be. So I've just made a mark at 2 centimetres there for my sun. 2 centimetres from my margin here. Sorry if that's not very visible, I'll make that margin a bit darker. Here's my mark for my sun, and I'm just going to, I'm not going to use a compass this time, just going to draw a slight semicircle for the sun, and there we go. And from there I'm going to draw a line across the page which should be 38 centimetres. I'll do it in pen so you can see it a bit easier. That's 30 to there. And yeah, 38 centimetres in total, another 8 centimetres on the end. So I've gone from 2 centimetres, and right at the end there is going to be Neptune, isn't it? I'll put it as close as I can to the end of the sheet, and I know that's Neptune. Sorry, everything's backwards. The way you're looking at it is around the wrong way to me. There's Neptune, here's the sun. You'll just have to realise that I'm doing it the opposite way round. Okay, and remembering we're going to be dividing all our squares of toilet paper by 2, and that will get us our centimetres along the way. Reason why we're dividing it by 2 is because I've got 38 centimetres of space up from the sun to Neptune. So we'll start with Neptune first, which is 76.3, just to show why we're dividing by 2, because I know that's going to get me about 38 centimetres. 76.3 divided by 2. How many 2's are in 7? There are 3 2's in 7. 2 times 3 is 6. That leaves 1 left over. We put that there. That's 16. How many 2's in 16? There are 8. There's my 38. Decimal point needs to be in the answer as well, above where it is in the question. How many 2's are in 3? There is 1 2 in 3. If I stick a 0 here, add another column. I've got 1 left over because 2 times 1 is 2. This is 3, so 3 is 1 more than 2. So I put the 1 there. That's 10. How many 2's are in 10? There are 5 2's in 10. So 38.15. I've started with Neptune just to show you why we're dividing by 2, because I knew that Neptune divided by 2 would give us about the space that we need to have on that page, 38 centimetres. Okay, let's have a go at some of these. You've seen me do this one already, but I'll just refresh. 1.0, otherwise known to us as 1, divided by 2. How many 2's are in 1? There are 0 2's in 1. Put the decimal point in. We need to use that 1 though, so we put it over here instead. Make that 1 10/10 instead. How many 2's are in 10? There are 5. So that being Mercury, that will be 0.5 centimetres. I'll put that there to remind me, centimetres. Okay, Venus, 1.8 divided by 2. How many 2's are in 1? There are 0. Add the decimal point. Put the 1 here. How many 2's are in 18? There are 9. So that'll be 0.9 centimetres. And it's 0.9 centimetres from the sun. It's not 0.9 centimetres from where the Mercury bit is. Okay, Earth. Earth, 2.5 divided by 2. How many 2's are in 2? There are 1. Put the decimal point in the answer because it's in the question. How many 2's are in 5? There are 2. 2 2's are 4, which leaves 1 left over. If I add a 0 here, so I've got an extra column, I'll put the 1 here. How many 2's are in 10? There are 5. So that's 1.25 centimetres for Earth. Mars, 3.8 divided by 2. How many 2's are in 3? There are 1, with 1 left over. I need the decimal point there. How many 2's are in 18? There are 9, 1.9 centimetres. Obviously, these numbers are going to get bigger every time. Jupiter, 13.2 divided by 2. How many 2's are in 1? There are 0. So I'll put these two together. How many 2's are in 13? Well, 6 2's make 12, so that'll be 6. 12 is 1 less than 13, so I'll put the 1 here. How many 2's are in 12? 6. So it'll be 6.6 centimetres. Don't really need this 0 here. 24.2 divided by 2. That'll be 1 2 makes 2. 2 2's make 4. Add the decimal point. 1 times 2 is 2. 12.1 centimetres for Saturn. We've done Neptune at the bottom, so only Uranus to go. 48.6 divided by 2. That'll be 2. 4. 2 times 2 is 4. 2 times 4 is 8. Add the decimal point. 2 times 3 is 6. 24.3 centimetres. So now I know all my measurements. Back onto the paper any moment. Okay, so I've written it on my piece of paper. Mercury is going to be 0.5 centimetres from the Sun, Venus 0.9, Earth 1.25, and Mars 1.9 centimetres. Those are all closely packed together, so I have to be very careful with my measuring on those. As we get a bit further away, there's bigger gaps between the planets, so it's not quite so vital that I'll get it absolutely spot on for the others, but I need to keep these apart, and I need to make sure I'm measuring 0.5 centimetres. So doing this whilst holding the iPad at the same time is fairly challenging, but there's the Sun. I've got it on 0, so this is 0.5 centimetres, it's 5 millimetres, so that's where I'm going to put a line for Mercury. And then 0.9, it will just be the little line before 1 centimetre, so that's where I'll put a line for Venus. 1.25, well, there's 1.5, there's 1, so it's about halfway in between, it's going to be about there. And 1.9 will be just before 2 centimetres, so it's 1 centimetre and 9 of these millimetres, which I seem to have an ink stain helpfully blocking out there. Okay, so I'm going to put arrows for those on 0.5, 0.9, 1.25 and 1.9. I'll alternate it, so I'll have one arrow above, the next arrow below, one arrow above, the next arrow below, just so that they don't get in each other's way too much. And there are the lines for the first 4 planets. There's the Sun. And now I'm going to draw arrows and annotate with the names of the planets for those. Okay, I messed up a little bit. I should have put Mercury's details right up at the top there, because I ended up having to put Earth's arrow kind of through it. Same with Venus. I should have put that down the bottom here, and Mars higher up, but you get the idea. Mercury and how far it is away from the Sun, pointing down at its little notch on the timeline. Venus here, Mars here, Earth slightly closer than Mars. Okay, on to Jupiter, which is 6.6 centimetres, and Saturn, which is 12.1 centimetres. And for those who are not sure what I'm referring to, it's in thousands of kilometres here. I've changed it into millions. So 57,910,000 kilometres. I've changed to 57.91 kilometres. Million kilometres, that is. Equally, 108,200,000. I've changed to 108.2 million. It's the same thing. So Saturn, Jupiter, 6.6 centimetres. Saturn, 12.1 centimetres. Let's get that notched on the ruler. There's from the Sun, 6.6 centimetres. Is there. Oops. 12.1 centimetres for Jupiter. You have no idea how difficult that is. This is holding an iPad at the same time. 24.3 centimetres for Uranus, or Uranus. About there. And Neptune we've already done down the other end. There we go. Jupiter, 778.33 million kilometres from the Sun. Saturn, 1,429.4 million kilometres from the Sun, or 1.429 billion if you prefer. Uranus, 2,870.99 million kilometres from the Sun, or 2.87 billion. And Neptune, 4,504 million kilometres from the Sun, or 4.5 billion if you prefer. Okay, time to draw some circles. Yikes. Hopefully this will be take one and only with the compass. I'll try to be honest if it isn't. Right. Thing most people get wrong. They have to be even, okay? Don't just put it in like this with them not even, with the pencil being way lower or way higher, okay? Put them in both on the paper and then tighten. That way you know they're on the same level. Okay, plant the metal bit in, hold the compass on the top and just turn. Have to go both ways normally, unless you're double, triple jointed. Sometimes you have to just swap hands. So I've grabbed it with the other hand, hold it still in place, and eventually you will join the circle round there. Not too bad at all, not too bad. And depending on how big you want the circle to be, it's just how far apart you want them, isn't it? Okay, if you measure between the two, that will give you half of the diameter of the circle. We call this the radius. So if you've got a circle, a line all the way across the middle, that's the diameter there. Half of that from the middle to one of the sides is the radius, and all the way around is the circumference. And you can calculate how big one is going to be from the other, but we're not going to do that today. That's saved for another maths lesson, probably later in year 5. Okay, I'm glad that worked out well. I'm going to draw myself some planets, and I will show you the results in a bit. When you're drawing the planets, we won't go for exact measurements or exact comparisons. All we really need to know is that Jupiter is the biggest, followed by Saturn. There's not much to choose between Venus, Earth, Uranus and Neptune. They're all about the same size. And then Mercury and Mars are slightly smaller than those. So Mercury and Mars will be my smallest. Then we've got Venus, Earth, Uranus and Neptune similar. Saturn quite a bit bigger than them. And Jupiter bigger than Saturn still. I promised they were all fine first time. So here we have Mercury, Earth, Venus and Mars. So I'm going to keep the same setting for Earth that I had for Earth for Uranus here. In fact, let's put it down here. Plant that firmly in. You can do it at a little bit of an angle and turn. Don't worry if it's a bit faint first time. As long as you've got it solidly in, you can go over it and back round. You can just keep going round on yourself. Round. Don't expect to do it all perfectly first time. Patience is the key. And there we go, not a bad circle. Okay, one more for Neptune. Where can you see it best? Here, right. Let's put Neptune here. Probably could have put it a little bit closer to the arrow, to be honest. Oh, there we go. These compasses aren't bad actually, better than the ones we had in the past. And there is Neptune. Saturn is going to be a bit bigger, so I'll just widen this a tad. And I'll put this up here. Making sure I've got space, that it's not going to go into my writing. No, that's going to be a bit too big. Let's see. Maybe I'll stick it down here actually. No, here. Oh dear, it's all gone a bit peaked on. Right. That's all right. If you make a mistake, just adjust the pencil so that it's back level on the line where it was going well. And then just have another go. And don't be afraid to swap hands. And don't be afraid to just guide it. You can actually just guide it round and hold on to the pencil end as long as the pointy bit is firmly in the middle. And there we go. There's a tiny mistake there, but I can rub that out no problem. You can't see it. Just a little bit of a mistake, but we kept the compass where it was. And I'll put a ring around that in a minute for Saturn. And then finally one last one here for Jupiter. Bigger still. Nice big space. I might just have it overlap with the writing actually. Just go over and through the writing. Just so it's in the right kind of place. And just hold that and bring it round. And there we are. Went a little bit wrong at the end, but I can tidy that a little bit up here. And no one but you and I will ever know I made the mistake. Okay, I'm going to colour these in, put a ring round Saturn, give it a title, and we are done here. And here we have the final product. And if you notice in the middle here, I've done what's called a key. So I've looked at Venus, which was closest to 1 centimetre at 0.9, and that was the equivalent to 108.2 million kilometres from the Sun. So I've rounded that distance up and the 0.99 centimetres away from the Sun. I've said that approximately 1 centimetre on this line equals 109 million kilometres.